Welcome to today's webinar on why an SBOM is critical for cybersecurity and how to create one. So those of you on this webinar probably already know that an SBOM stands for Software Bill of Materials. And we're going to be hearing from some experts today about the SBOM, how you might think about it, what you might use it for, and how to create one. So let's start with some housekeeping items. So Dan, if you can move, thank you very much. So all the participant slides, will be muted, and we're going to do a Q&A at the end. So you can answer any or ask any questions on the questions panel of your GoToWebinar control panel. You can ask those at any point, and then we'll take as many of those questions as we can at the end. After the webinar, within the next 24 hours, you should be receiving an email with a link to the recording. So look for that if you want to review or share with others in your organization. If you need the actual slides, go ahead and shoot me a note in the questions panel, and we can have somebody follow up and actually provide you the slide version. And then lastly, at the end of the webinar, after we do the questions, there's going to be, as you exit, a short feedback survey. It's like 3 quick questions. We'd love it if you would fill it out because it gives us great feedback about the webinar and how we might improve in the future. All right, so let's move on and just mention, in case you are new to Encore and may not be familiar with who we are, Encore is focused on software that helps you secure your cloud-native software supply chain. So the idea is that you can embed continuous security and compliance checks all the way through your development process so that you can fix any security issues earlier in the process, thereby lowering the cost and time to remediate. So if you're interested in learning more about Encore, we're of course happy to talk to you after the webinar. All right, let's just go over the agenda really quickly. We'll be talking today about what an SBOM is, why you might need one, how an SBOM applies in the world of containers, which is the main way that people are delivering cloud-native applications today. We'll talk a little bit about the SBOM standards that are out there and what are the differences and how you might use those. We'll talk about SBOM normalization and different approaches to that and how we approach it. We'll give a quick demo of our open source SBOM generator called Sift, and then we'll do Q&A. So I want to start by doing a few polling questions just to get a sense of the audience, and then you guys can get a sense of each other as well. So we're going to do 3 polling questions. These will be pretty quick. So the first one is, what is the current use of SBOMs in your organization? So are these things that you're currently using, not at all, not sure, or you're not using yet? Are you providing them to external customers or just using them maybe for identifying open source licenses or for compliance purposes or for security purposes? So you can check more than one here. So select all the ones that apply in your organization. And I'm going to give you a few more seconds here for everybody to get their votes in. If you're not using them yet, then you can just select none or not sure. All right, it looks like most of you have got your votes in. There we go, one more coming in. Let me go ahead and close the poll, and I'm going to share the results with you. So half of you are just still in the beginning stages of SBOMs, and by the way, that was about what we expected coming into this webinar that we would see, is that people, it's still early days. 20% using using it to identify open source licenses. So that's been probably the longest running use of SBOMs. It's been around the longest. 20% for compliance purposes, 40% for security purposes, and 20% providing it to external customers. All right, let's do our second question. And this one is going to be, how much do you see your organization's use of SBOMs changing in the next 24 months? Is it going to go up or down? How much? Stay about the same? So again, this one you just select one instead of multiple. So I'll give you guys a few seconds to pick the one that you think is most relevant to your organization. Let you get those votes in. All right, we'll go ahead and we'll close the poll and share the results with you. So half of you increase significantly, 10% increase somewhat, and 40% stay about the same. So it's pretty much going to stay the same or go up. All right, one final question, which is, for which of the following types of artifacts are you producing SBOMs? So are you creating an SBOM just against raw source code? And again, you can pick multiple here. The actual executable or the build of the application? Are you doing it against container images, published software, like software that's going outside of your organization to customers, or none of the above, or not sure? So I'll give you a few more seconds to get all of your check marks set up there. All right, we'll go ahead and we'll close the poll and share the results with you. So interestingly, 40% of you already doing it on container images, which is great, which since container images are sort of the new way of the future, and we know they generally contain a lot of open source, 30% against source code, 20% executables, 30% published software, and 40% none or not sure. All right, thank you so much for taking that survey. Let me go ahead and introduce our speakers, and then I'm going to turn it over to them to get rolling. So today you're going to be hearing first from Daniel Nurmi, who's our CTO and co-founder here at Encore. He'll start us off, and then later you'll be hearing from Alex Goodman, a senior software engineer here at Encore, who focuses on our open source solutions. So take it away, Dan.
All right, thank you very much, Kim, and thank you all for attending this webinar today from Encore. This is Dan Nurmi. As Kim just mentioned, I'm the CTO co-founder here at Encore, and yep, we're going to talk about software bill of materials. So to get started, I just wanted to kind of go over a general overview of what a modern DevOps toolchain looks like. And it sounds like from the polling questions, many here, who are working with containers, might already be familiar with this, but just to set the stage about, where SBOMs really fall into the DevOps toolchain story, kind of goes back to how these processes work from modern organizations. So most users and customers that we work with have or are developing an automated process that looks something like this when it comes to building application software or even consuming software from some provider and getting it either published or deployed. Where on the left-hand side of this process, we've got actual application source code where developers are adding new features or writing new applications, doing bug fixes, things like that. And then on the right-hand side, we're either taking all of that work and bundling it up into something that's published for customers of the organization to download and consume, or it simply is deployed. Like for an internal use case, we might be building an application and then deploying it into our own internal environments in order to leverage and use that application. And then everything in between, right? We're seeing just this increased amount of automation and a lot of very sophisticated tooling that's really bringing together development, operations, and now security and compliance into the same kind of mechanism. So we have source code, we do development, builds happen automatically. There's testing that goes on for QA or other types of functional tests. There's typically some kind of staging environment or part of this spectrum where everything is now ready to go, and there's final steps like signing or bundling it up for publication or deployment, and then finally that last stage, which is customer facing. And one of the interesting things about this that's a bit new, especially when it comes to containers, is, as I mentioned, the degree of automation. And where everything in this process becomes more and more automated, we also see an increased sort of frequency and variance happening here. We work with some users and customers where, for example, every single commit of a change, whether it's a new feature, a bug fix, security update, anything, will kick off this process and actually generate new pieces of software and artifacts at every stage of this situation. And this is kind of where SBOMs start to become interesting. Now, if we look at along the bottom here, we've got those general stages: source code, the application gets built, container images are created with the application inside. We've got either running containers or published software over there on the right. SBOMs are documents that can be created against any of the artifacts generated at each of these stages, and they have a lot of information in them that's associated with that artifact. So, for example, in the source code side, the source code is the artifact, and an SBOM can be generated against that artifact and associated with that exact version of source code. In the application build side, we've got now an executable, and there's also an SBOM that can be generated associated with that, and on and on. Typically, what these SBOMs have in them are a number of things. Some of it is dependent on which stage you're in or the artifact that you're generating the SBOM against. Some of them are pretty common across all of the artifacts that get generated. And there are things like the application software itself, the name of it, the version, its checksums, things like that. There's also a very important element of most SBOM use cases are the application dependencies. These can be open source dependencies of your application that's pulling in. They can be other vendor dependencies. They can be operating system dependencies in the case of container images, which we'll see in a second. Open source licenses, which is something that came up as a prevalent use case for SBOMs in the poll. Checksums and hashes of all these elements so that you can really dig in deep and figure out exactly what these artifacts are made of and how they're composed. And finally, there's artifact-specific metadata, and Alex is going to talk a little bit more about that in his section. Now, with these SBOMs, what do we need them for, right? And so there's definitely some use cases that we've seen SBOMs being used for within organizations today, but there's also some new use cases that are starting to emerge that's really putting more attention into the usages of SBOMs, and we're seeing more demand for SBOMs from various organizations and types of uses. So if we now look at the left-hand side, we've got all of our artifact types. Let's assume we're creating SBOMs for all of these types as changes are being made and everything's automated. New artifacts are being generated all the time. The first general category of usage is for internal cases. Compliance review is definitely something that organizations will use SBOMs for. That's for some of the typical compliance standards, PCI and HIPAA and other types of NIST standards. Every so often, an organization might have a compliance team that comes in and needs to do a review. A major element that gets fed into that review can be software bill of materials, because they articulate at every point in time, here's exactly what the system has been producing. And those review processes can take that information both as proof of compliance, but also to review if something was out of compliance, what happened to actually remediate it. SBOMs can be used for that. Security assessment internally is definitely another use case. A lot of security tools and organizations like Encore actually use SBOMs to do not all of the security assessment stuff that we do, but certainly some of it. We take SBOMs, can look at public sources of vulnerability information and use those two pieces of data to combine and map. Your SBOM has these versions of software. The vulnerability information available says this software is vulnerable, and then we can actually map and associate securities violations directly to artifacts via the SBOM. License compliance is another one, whether it's open source or commercial licenses. The SBOMs contain that information, and so compliance can be done against those. And finally, a little bit more of a subtle one is quality assurance, which we'll talk about in a second. In addition to the internal usage of SBOMs, oftentimes we're actually, as an organization that produces software, is asked to actually produce software bill of materials or some kind of information for cross-organizational purposes. Like a customer might come in and ask for a license overview of software that they just bought from your organization. And that ask can be accommodated by supplying SBOMs, both for external compliance, but also just contractual customer audits. Oftentimes SBOMs can be used to support those use cases as well. So moving on, we're going to look now at some of the specific use cases and why these things are starting to become more a part of the conversation. We've seen software bill of materials being mentioned more often, in articles about security incidents, about compliance incidents, just general cross-organizational collaboration, where I think correctly, a lot of folks have identified if we had richer, better, more prevalent, more controlled software bill of materials, then it actually moves the needle. We're able to have some of these cross-organizational conversations more effectively. So the first one is definitely around security incidents. Oftentimes, we're seeing more and more organizations actually asking for security assessments or security practices that include the requirement to be generating software bill of materials for security assessment purposes. Whether it's an external compliance audit or a customer contract audit, we're starting to see more and more requests from say, a new customer asking directly about your internal security assessment protocols, and the ability to produce software bill of materials as a way to do security assessments often satisfies those requests. The second one is about cross-organizational compliance. And this one, I think, is a little bit new. As Kim was mentioning earlier, I think the traditional version of this has really been focused a lot about license compliance, and often more specifically about open source license compliance. So a customer might have their own license constraints saying these open source licenses are acceptable, these ones aren't, or if the software that we're consuming has dependencies or anything according to these certain open source licenses, we at least need to know about it. That's kind of the traditional use case for this type of software and bill of material across the organizational boundary. But we're also starting to see more questions coming in from external larger customers that are actually asking about quality assurance, making sure that not only are the licenses enumerated, but also that your software is up to date. So they'll look at, say, your list of dependencies and start noting, well, this dependency is really old. Maybe that's of concern. We're actually asking for some quality assurance information, and SBOMs are a great way to produce that automatically. The next use case that's pretty interesting is really a bit more new as well, and it really comes down to this notion of DevSecOps automation. So as organizations are using containers more and automating a lot of these processes, these internal procedures of compliance review, security assessment, license compliance checks happening all of the time and happening automatically are really only possible if we start to generate more of these software bill of materials at every stage, because there's so much happening. Like I was talking about earlier, organizations that have a system in place where every code commit generates a brand new set of artifacts across this DevOps pipeline. It's not really feasible for each iteration for a team of human beings to go in and do all of these assessments manually. And so instead of that, we're one of the companies and sort of projects that tries to make it possible to do these types of audits and checks automatically as these things are happening. And this is something where SBOMs are a major element of our ability to do these kind of checks and assessments and in an automated fashion. And finally, there's this one that's a little bit more subtle. It comes down to the complexity of your applications. And that's related again to this high frequency, lots of artifacts being generated all the time, situation that we find ourselves in. There's definitely new practices that we're seeing about quality assurance, and that kind of goes back to those new customer requests where customers are starting to ask for up-to-datedness reports of your dependencies, making sure that everything that is being supplied is not super out of date or very old or unhealthy in some way. And this applies also to the internal usage, where there are now teams that are watching their developers and finding that, well, the developers are really good at the applications that they're writing. That's where the expertise lives, but it's not necessarily guaranteed that when we're building our applications into containers, that perhaps that base image might be very old and hasn't been updated in a while. So these types of SBOMs can really surface that information, allowing the DevSecOps teams to identify when, while the application code might be moving along at a fair clip, some of their dependencies or the base images that containers are being built on top of might not have been updated. So trying to keep everything moving forward at a reasonably consistent pace is something that we're seeing SBOMs used for as well. And finally, just when it comes to containers specifically, we've talked generally about what SBOMs are. Containers are a really important element of this story because it's kind of the last encapsulated artifact, where a container can be the artifact that a customer uses. It can be the artifact that gets deployed, the actual thing. And it's actually pretty interesting to look at what containers are made of, right? It's not just the application code, which actually increases the sort of prominence and importance of software bill of materials, specifically against containers. Containers can have, also secrets and credentials inside. They can have data and other files in support of the application code. They've got all of the applications, dependencies and libraries that come in support of the application. And as an encapsulated execution environment, they also typically come with almost an entire lightweight operating system. That's often the case. And that means there's operating system packages and OS configurations and open source licenses associated with those elements as well. So a container SBOM has all of that information in it, which is important because those are the things that are asked for from the external customer and useful for these internal use cases as well. So I think with that, I'm going to turn it over to Alex, who's going to talk more in detail about software bill of materials, what they look like, how they're composed, some of the standards, and do some demos.
Awesome. Thanks, Dan. So yeah, my name is Alex Goodman. I'm one of the developers here at Encore, working a lot of the open source tooling. And I wanted to start chatting today about the existing SBOM formats. And there are plenty of SBOM formats out in the world. So these three are very popular, but you could probably list another 10 or so that we didn't really have a lot of time for. So so here we have SPDX, CycloneDX, and Software ID. So all three of these formats are very popular. That Software ID started around 2009. SPDX came shortly thereafter, and CycloneDX is more recent and is backed by a open source community, backed by an industry working group. For the various formats, you'll see that SPDX has several different supported formats. CycloneDX has fewer, but if you check out their GitHub org, you'll find lots of ecosystem integrations, which is very helpful. I think one of the more interesting things to note about Software ID is that they're currently drafting out a new co-SWID, the CBOR format for memory efficient formats, which is I think going to be interesting for the future. But going into some of the history of this stuff, so the original use case for SPDX was for license management. And so some of the unique features around it is this extensive support to express licensing details. For CycloneDX, it was originally for use with OWASP dependency track software, and has been extended to cover more use cases. One of the more useful I'd say unique features that it has a very extensible format. You could bring your own extension. You can also bring your own attributes, and it plays pretty friendly with other ecosystems such as the SPDX license IDs and Perls and other external identifiers. Yeah, and for a software ID, its original intent was for inventory and change tracking, where you bring software ID tags with the software being deployed. So it's very deeply ingrained with the build and publishing process of your particular software. I think if you fast forward to today, all three of these tend to now cover the same case. They've gone outside of their original use case, and they're more generic, where they can track attributes of multiple software components and all the metadata associated with it, and the relationships between them. They're able to describe more than just like a set of packages, and they're able to provide metadata that's useful for checking the integrity of the software components and constituent components. So what makes like a good SBOM? So a good SBOM is, at the very least, is describe like what is being cataloged. Is it a container image? Is it a VM? Is it a running VM? Is it a machine image? Is it an archive, a tar? What is it that is being cataloged? And then it gets to the details of, okay, now that I have this one thing being cataloged, what is actually inside of it? So for each catalog item, you have the name, the version, something to uniquely identify that element, because you may have two of the same name and versions within even the same ecosystem or across ecosystems. So it's very useful to have some unique identifier there. And well, the reason why that would be useful is because tracking relationships between these things is very useful. So for instance, I may have a jar that contains another jar, or I may have a piece of software that is a dependency of another one. I may have a package that is in my SBOM, that is in my artifact, but it has a source package that is not contained within my artifact, but it's useful for downstream purposes. So relationships are a subtle but very useful thing. And lastly, the SBOM should describe like what actually did the cataloging. So typically you're not finding like individual folks going out and manually crafting these things. So it makes sense to at least describe the tool that created the SBOM. So, and say the configuration that came with it. So if you have a way to configure your SBOM generator tool, you should be bringing that configuration into the SBOM document such that somebody can reproduce the same result with the same configuration. And this is kind of the entry point for like what makes a good SBOM. But what really stands out for like a great SBOM includes things such as like the SBOM should self-describe what is in scope and what is out of scope for the cataloging process. So for instance, if I'm looking at a system and I'm trying to create an SBOM for all the things running on that system that are installed on that system, including which paths were searched, or if I'm searching everything, include a set of paths that are not included. Or, hey, maybe I'm only looking for these kinds of packages and not these other kinds of packages. So in that same vein, noting any exceptional conditions when you're going through the cataloging process. So it may be that you're searching for jars, but in one of the jars that you found, you had a jar that couldn't be opened because it was malformed in some way, shape, or form. It's kind of a tricky situation. Like, do you want to like stop the entire process and say, like, I can't create an SBOM? Or do you want to continue forth and at least create an SBOM? But you don't want to create an SBOM that looks like it has everything, that has cataloged everything when there may have been something it has missed. So in the SBOM itself, you should be noting these exceptional conditions that like, hey, I couldn't read this file. So there may be other packages that were missed. Or say environmental factors. If you're expecting, say you're on a VM and you're trying to catalog your VM, and you are expecting some shared drives to be mounted, and those are missing, so that would be important. And lastly, keeping in mind any metadata that is going to be useful downstream in any analysis that you're doing. So so just capturing the Java name and the version may not be good enough. Like you may actually want to head into the specific like Java POM properties and grab all the key values out of there, because that may be useful for some analysis that you're doing downstream, grabbing specific licensing information. Sometimes that's useful, sometimes that's not. Just depends what your use case is. The idea is an SBOM should be pretty self-describing. Like, you should be able to take your SBOM and give it to somebody else, and they should be able to tell you all of these attributes. Like, oh, I could tell that you searched this kind of thing. You used this tool. You had this configuration for this tool. I could reproduce it, and I could tell you what were the things that you were looking for and what were you not looking for, and what were the problems that you had. So you should be able to deduce all these things just by giving someone your SBOM result. So we want to talk a little bit about Sift. We have an open source tool called Sift. It's used for generating SBOMs for both container images as well as file systems. It supports several packaging ecosystems and several different Linux distros as well, and as well as multiple output formats. So we have summary table, JSON details, CycloneDX, and SPDX is coming soon. We have a branch for it. So yeah, and with regard to Sift and how it fits into the larger Encore ecosystem. So Sift is step one. So you bring what you're trying to analyze to Sift, so whether it be the container image or a source repo, so a file system, etc. Sift will generate an SBOM document for you. You can take that SBOM and you can upload that into Encore Enterprise, where you can get your vulnerability analysis, your policy assessment, etc. You can also take that SBOM and you can feed that into Gripe, our open source vulnerability scanner, and also get vulnerability JSON. And you can also bring that SBOM to any other customer system that you can think of that would help out in your particular use case. But this is how Sift fits into the larger Encore ecosystem. One of the things that we are careful to think about when we're diving into SBOM generation is when to normalize information versus when to not. So when you're so all SBOM formats, they need to normalize the information that you find in the raw source to some standard data shape. This process of normalizing is lossy. So you're preserving just the right information in order to describe, here's what's in this source, so container image, etc. So in this example here, we have at least 4 packages, maybe more. They come from, we can grab all this raw information from some YAML formats, JSON, TOML, maybe a Berkeley DB entry, and maybe megs. They could be megs and megs in size, but ultimately we want this tool to not give us all the raw information. We want something distilled down into a small format where we can take that and bring it along, but we want to be not too lossy. The idea is you want to pick an SBOM format that has this right balance of normalized versus preserved information based off of your specific needs. So in that same vein, I want to jump into a specific example of 2 packages with Sift and this JSON output where this trade-off has been made. So on the left is a dpackage description for a package called libhogweed, and on the right, WSGI-ref it's a Python package. At the top, you have all the normalized information. It's the information that we think is pretty common across all packages, no matter what ecosystem it's coming from. The name, the version, what found it, where did we find it, the licenses, the language, etc. But then down the second half of the blue section, you'll see that there's this metadata field that just kind of has it's a bag of key value pairs. And so the only hint is this metadata type in this normalized section. Or on the left, you'll see metadata type, dpackage metadata, and then you see a lot of dpackage specific information. On the right, it's the same thing. You'll see Python package metadata, and you'll see a lot of specific Python package information. And something to note is like you may see fields that are very tempting to take out and to normalize. So on the left, there's maintainer. It has a name and it has an email address. On the right, we have metadata, and there's 2 fields, author and author email. So this is the same kind of information, and we could have made the decision to take that and to normalize it into a section up above. But we instead decided not to. We tried to keep only the most general information that was common to all ecosystems in a normalized form up above in these sections. And everything else should stay as ecosystem specific, whichever ecosystem that is, in simple key value pairs. So for instance, these key names have not even really been changed. If we found these keys as they were, so these keys are as they were found down in the raw configuration formats that we parse them from. So this is very useful for, say, in the context of, in our context, so we make a vulnerability scanner called Gripe, and Gripe uses a lot of this raw information to just go one step further on trying to find vulnerabilities for packages. So for instance, so this libhogweed on the left here, it has a listing for source. So dpackage has it tracks source packages upstream from the source field and from where we parse this from. If we were to look up vulnerabilities for specifically this libhogweed, we would not find a lot of hits. But if we were to look for the upstream package nettle, we would find more because the maintainers are tracking a lot of the vulnerabilities in the upstream source package. So that's an example where we want to try to preserve this ecosystem-specific information for our specific use case of vulnerability scanning. It's very useful to us. So yeah, that being said, let's jump into a demo of Sift. So here on my terminal, I've got in this directory a directory Prometheus. This is a cloned repo from Prometheus's repo. So I can use Sift here to we have Go modules that were found. So here are the specific Go packages for Prometheus. So that was the directory scan. So taking Sift and pointing it to a directory and saying, find me what you can in here from some declarative files. Additionally, we can use Sift to take a look at container images. So I'll take a look at the Ubuntu latest image, the base image. It's a very same output. This is a summary table showing the name, version, and type for the 92 packages in the Ubuntu latest container image. And I can change this format to say CycloneDX if I wanted to take this and use it as a dependency track. So ta-da! So now we have the same output, but instead in CycloneDX, taking all of the relevant information. But this is a lot more information. Like where did all this extra information come from if I was only showing a summary table? So we also have a in-house JSON format as well that persists as much information as possible from what we glean from the underlying information. So just by saying -o JSON, we have all of this information, lots and lots of information that can be very useful for various kinds of analyses that you're doing downstream. So I don't think I'll enumerate through all of it, but so you also have that at your disposal. So that's it in a nutshell. I want to show also Gripe. So Gripe is our vulnerability scanner. So if I take a look at the Ubuntu base image, for our 92 package that Sift was able to find previously, we found 26 vulnerabilities in that image. And so what's happening when we run Gripe? Gripe is using Sift under the hood as a library. And so these first few steps here, for loading, parsing, and cataloging, that is all being done by Sift. Sift is going in and pulling the image, unpacking it, looking through all the files, and then doing the cataloging process to generate an SBOM. And then the step after that is the last step is to actually go and do the vulnerability matching to get these results of packages matched up with vulnerabilities. So that's actually a lot of work for Gripe to be doing. And so I wanted to show what happens when you have, say, like a very large image. So I'm going to do a split screen here, where on the top, I'm going to give Gripe a large image that has a lot of packages in it. And I want to note that earlier, I went ahead and took some time to go ahead and grab that SBOM. So I have the raw JSON SBOM already created, and I want to use Gripe, but instead of having Gripe go and look at all the nitty-gritty details and create an SBOM itself, I'm going to say, take my CloudBees SBOM that I've already generated. So I'm going to kick these off at the same time. All right. So up top, it's still loading the image and trying to grab all the raw bytes for analysis, whereas right here on the bottom, it's already scanned the image before I was even able to explain what it was doing. So by using that SBOM, it was able to cut a lot of steps out of the process. So we found our set of vulnerabilities for this particular image, and we can take the results and go forth. Whereas Gripe is still like churning on, creating the SBOM, and then going off and doing the scanning process. So what is the diff? It looks like it's just about done here. So down below, that took just about 10 seconds. And up here, this is going to be something like 40 seconds. So why is that important? If you create a artifact, so 50 seconds. Cool. So if you create an artifact, so say you're creating your container image, say your release cadence is every couple of weeks. Now, vulnerabilities are coming out, are being discovered every day, and are being put into our database. So you will need to scan your image more often than you create it. Scanning that raw image takes a good amount of time the more information that you have in it. So persisting your SBOM, so keeping your SBOM around with your artifact when you create it. So when you're going through and you're creating your Docker image, going ahead and doing due diligence and creating your SBOM is a pretty good best practice, because you could always take that SBOM document and run it against, say, a vulnerability scanner on a daily basis, and it's very cheap relative to, say, taking your raw image and running it against a vulnerability scanner on a daily basis. So yeah, that is all that I had to demo. So thank you very much.
All right, thank you, Alex. So just, I think in summary, we've talked about SBOMs, kind of what they are, how they're being used today, and some of the use cases we're starting to see, emerging. It's definitely become clear to us, and I think others that we work with on a daily basis, that these types of software bill of materials documents and the quality of them becoming much more critical as time moves forward in the whole area of software supply chain security, right? And the reason for that, I think, if it hasn't become sort of apparent through this presentation, really comes down to the fact that a lot of our security practices have to do with insight and awareness. Like having access to high quality information helps for not only the kind of vulnerability enforcement and prevention kind of areas of security, but also in terms of the forensics and impact assessment. When a security incident happens, a lot of times the security team might need what's running, right? That kind of stuff. And it turns out software bill of materials is a really important foundation to be able to supply that information, both for automated processes and for these specific security processes going on. It's important to select the type of SBOM standard that's based on your specific needs. I think as Alex went through, there are differences in the standards. We're interested in all of them, but they all have different qualities, and some of them might impact your processes to take those documents and do something with them. It's pretty important that whatever SBOM generation tool or procedure you choose provides the right level of usable detail required for not just a specific use case, but hopefully through this presentation you can see if you get it right, SBOMs can be used for a lot of different use cases. So choosing the right one that has enough information in it, we think is important. And there's always this notion of it's a good practice, we suggest, to start preserving these software bill of materials associated with all of the artifacts that your DevOps toolchain is producing as soon as possible, right? There's so many use cases for them. Having them associated with the artifacts being generated by your org is something that we believe is going to continue to be an important element. And finally, as we move forward, and this is kind of specifically for software suppliers like Encore, for example, we're starting to see more of these cross-organizational requests coming in from federal government, from customers, from all sorts of places who are looking at supply chain security as a prominent issue. The SBOM is one of the artifacts that can really help to communicate what's going on between what you're doing as a supplier and what the consumer is actually looking for. If you imagine if all of the suppliers were starting to produce SBOMs and supply them to their consumers throughout the chain, there's actually better global visibility across these situations. So we think that's pretty important. So I think with that, thank you very much. We'll probably hand it back to Kim to wrap up.
Great. So we're going to do Q&A. We got a few questions that have come in, but if you have additional ones, please add them. One quick note here is if you want access to Sift or Gripe, which are the two tools that you saw today, these are both open source and available on GitHub. So feel free to download those, check them out, and share any feedback on our GitHub projects. Also, if you like it, we'd love it if you'd give us a star on GitHub for any of those tools that you're using or have checked out. And then we do have a community Slack specifically for the open source community that's using these particular projects. And if you want to join that, you can use this URL to get there. It'll just ask you for email, which then it lets you sign in right away to the Slack community. So this isn't really our marketing stuff. This is really purely for open source discussion where you can talk to other users and also ask questions of our technical team. All right, so we have a couple of questions that have already come in. So let's start with the first one. Will you support .NET/NuGet in the future? A supplier of ours uses this.
Yeah, actually, NuGet is in the works for Sift. So I think it'll be coming in short order. If not this upcoming release, probably shortly thereafter. So soon.
Right. Okay, good. Coming soon.
There is an open issue track for that too on our issues in GitHub.
Right, so you can track that and see how it's going and see when that gets in. The second question is, do you support license categories, i.e. permissive, copyleft, etc., for compliance audit away, instead of just giving the specific license, but grouping them?
I'll take that one. So, Sift and the SBOM generator, it's an interesting question to say how much analysis of the data do you want to build into the SBOM generator versus the higher level, assessment. And our tactic right now in terms of those technology boundaries, and this might change, right? This is a very dynamic situation, but right now the SBOM generators at Encore will be producing the licenses themselves associated with all of the artifacts. And then, the assessment of those licenses and further categorization, we tend to think of as higher order operations on top of the data. So that being said, I mean, just in terms of a kind of a general architecture and approach, that's the approach that Encore's taking. But that being said, today we don't group them. We don't do an assessment of the license categories right now. What we do have in terms of assessment is to try to associate, if there's 5 different kind of variants of a known license, just in terms of verbiage and stuff, we do some analysis to try to group them into, well, these things are all LGPL, even though the specifics are a little bit different. Try to do some of that assessment.
And I don't know if this person is a user of Encore Enterprise, but I would guess if you did use Encore Enterprise, then you could leverage policies to do that for you. As another question is, like, how do generated reports look for the customer for internal purposes? So, I mean, here we showed more just raw output in terms of at the command line or the terminal. What kind of reports get generated, and what do those look like?
I think I can take that one as well. I think the question is probably about again, the sort of usage of the SBOMs when it comes to what, like, for example, Encore Enterprise is going to be producing using the SBOMs. And it's definitely more, of a report format, and you can get summary reports across all of your images or a filtered set of images. You can associate both the SBOM information with vulnerability assessments and policy assessments, all in single reports. When it comes to the software bill of materials reporting itself, we generally categorize them by, whether they're operating system packages and what types, whether they're NPMs, gems, we actually break these things out so you can look at the language ecosystem elements independently in a report. And in addition, there's an interesting feature there that actually looks at differences between SBOMs. And there's an interesting reporting mechanism in Enterprise where you can say, well, let's say we have a container that's called something latest as a tag, but it gets rebuilt every day or every week or every month. There's an interesting feature in Enterprise where you can actually say, well, here's the latest version of latest. How is it different from the last version of latest? And we used SBOMs to do that diff. And that can be a really useful reporting mechanism as well.
So that kind of leads to another question. In the demo, Alex, you showed how you could use the Sift SBOM to feed Gripe, and you talked about how once you generated an SBOM, you could rerun against Gripe because there might be changes in vulnerabilities, even if the container image itself had not changed. But given that these SBOMs can change over time, how would you go about triggering it to do a new SBOM, to generate a new SBOM when things had changed? What might that process look like?
Gotcha. Yeah. So the individual tools of Sift and Gripe are kind of the core. So you can think of Sift as all the business logic needed to raise the raw information to answer the question, what is in my image? Gripe is a detector of vulnerabilities. It will take that raw information and distill it down into a matching process. But when it comes to like putting that into a greater workflow, like, so, I want to take a look at my like Docker Hub and make certain that I have no vulnerabilities right now and at any point in the future, and as things change. That's what Enterprise is really great at. It takes these 2 great tools and it kind of puts them into a very larger workflows center pane of glass, where you can very simply say, point it to my Docker Hub repo, and I want to make certain that whenever something gets pushed, I want to kick off new scans. And under the hood, in the latest releases of Enterprise, Sift is being used in order to do that work. And I think in the upcoming releases, Gripe's going to be introduced for the matching process. So, so I guess TLDR, independently, they don't, but that's what Enterprise is for. So.
And if I may add, from an open source, if we also have some integrations with some of the common CI/CD systems like GitHub and GitLab, Jenkins, Circle CI. I mean, a lot of these tools are now set up in a way, and we've actually worked with folks in the community where you can build out a system that says, well, let's rerun the GitHub action that just does a gripe scan every day, right? It requires some more tooling and sort of stuff on your side to kind of wrap this stuff in some kind of process that you like. As Alex is mentioning, of course, Encore Enterprise, we try to make that process really integrated and simple, but there's a lot of different ways you can use this tooling to set up more automated continuous scanning.
All right, I have one final question, which I think we can fit in under the hour. So we have Alan Friedman with us, who's an expert in the SBOM because he's with the NTIA and has been involved in some of the SBOM formats. But he said, we see customer demand for SBOM for on-prem software. What are you seeing being asked for the modern applications, for on-prem versions of it? And how are you seeing customers use this? Is it simple vulnerability scans or more advanced use cases?
That's a good question. So I'll take the second one first. So we're actually seeing customers starting to associate SBOMs with deliverables. I think that's probably the most, the newest thing we're seeing out there, where it's not really common traditionally, as far as I've seen, to find like a download that's a zip file or a container image or something, and then right next to it, associated with it, no matter what, have a software bill of materials, right? And that's the kind of interesting thing that we're starting to see more organizations starting to do as software suppliers. So I think from just a pure SBOM perspective, it's metadata associated with things that you're going to be downloading and using as a consumer. From an internal use case, I think by far the most prevalent is for security assessments today, in our experience.
All right, perfect. Thank you, Dan. Thank you, Alex. Thanks everybody for joining. And if you guys can take the survey, the quick survey as you exit, that would be great. Go check out Sift and Gripe out on GitHub and communicate with us there. Or if you like it, join our community and give us a GitHub star.
Excellent. Thank you so much.